Hello. Today we're going to put together all the different stuff that we've been doing for quadratic functions for graphing and solving. So far we've talked about different forms for quadratic. We've talked about standard form, which is ax squared plus bx plus c. If a quadratic is in standard form, we can either solve it by using a quadratic formula or other method, or we could also graph it by doing negative b over 2a and plugging it in. We've also dealt a lot with factoring. So the factored form is going to have that quadratic either fully factored form. This sometimes is called the intercept form because your factors give you your solutions, which are your x-intercepts. The last one is vertex form. So vertex form deals with your transformations in terms of left, right, up, down, and stretching. And vertex form is really nice for graphing. So today what we're going to do is we're going to talk about how we can go in between those three different forms and convert between them so that we can either graph or solve or check our answers using various means. So this chart right here in the middle, this is going to help us get back and forth between the different forms. So given something in factored form, we can go to standard or vertex form by following the steps here. For factored form, we'd have to distribute to get it in standard form, and then we'd have to complete the square to get it in vertex form. So let's take a look at this first example here. It is in factored form, and we want to go to the other two forms. So in order to go from factored form to standard form, we're going to distribute. So I'm going to go ahead and distribute the two binomials to each other. I'm going to leave my coefficient out in front. The reason why I leave it out in front is because now, after I've distributed those, I can then distribute my coefficient. And I'll get f of x equals 3x squared minus 24x plus 36. If I were to try to distribute the 3 first, that is okay as long as you only distribute it to one factor. If you distribute it to both, you're double dipping and we can't do that. To go from standard form to vertex form, we're going to use the process of completing the square. So I'm going to go ahead and I'm going to factor the 3 out of the ax squared and bx term. And while I do that, I'm going to leave a plus blank inside my parentheses. And then I'm going to write a minus blank afterwards. And I have a coefficient of 3, so I need that to go on my minus blank. Because when I add a number here with completing the square, I'm really adding that number times 3. So to keep my equation balanced, I have to subtract that number times 3. So now I'm going to do b divided by 2 and square that and put that on the blank. So then all that's left is to factor. I would get x minus 4 squared. And then I have plus 36 and then minus 48. So it would be a minus 12. So all three of these are saying the exact same quadratic function, but just in different forms. So this can allow us to check different answers various ways by converting back and forth between them. Now what we're going to do is we're going to go from standard form both to factored form and vertex form. So since we just did one with vertex form, I'm just going to do the same thing again. I'm going to factor that 3 out of my ax squared plus bx term and write a plus blank and a minus blank. And that 3 coefficient has to go on my minus blank. I complete the square to find that c value of 1. And so in vertex form, it would be 3 parentheses x minus 1 squared minus 27. To go from standard form to factored form, we first are just going to factor this as if f of x were 0. So we're going to factor out a GCF. So we get x squared minus 2x minus 8. And so then we factor this to be x minus 4 and x plus 2, and we make sure our GCF of 3 is out in front there. So that would be your factored form or your intercept form, so we could find our solutions pretty nicely in that form. So let's do one more, one that starts in vertex form, and we have to go to standard form and then to factored form. So in vertex form, to get to standard form, I have to distribute everything out. So I need to do x plus 5 squared. And as a reminder, we're not just going to distribute the square, we have to view it as x plus 5 twice. So we have the negative 2 out in front. We get x squared plus 10x plus 25 when we distribute that. And we're going to distribute the negative 2 to get negative 2x squared minus 20x. And it would be negative 50 plus 6, so it would be negative 44. Now we're going to go from factored form to intercept form, so we're going to go ahead and factor out the negative 2 as our coefficient. So we get x squared plus 10x plus 22. And we're going to go ahead and try to factor from here. So we're looking for what multiplies to get 22 but adds to get 10, and there's nothing that works. So therefore there is no intercept form for this one, or no factored form. And the reason being, your x-intercepts either are going to be imaginary or they are going to be like something involving rational or irrational answers, like 1 plus the square root of 6 or something like that. So then for the rest of the day, I'm going to say go ahead and do the rest of the examples here, converting back and forth, and then just kind of reviewing graphing and factoring and different forms of functions. Let me know if you have any questions. Thank you.